Today, we will look at 5 of the best tools to generate Gaussian splatting. We will put them to the test to see how they compare in terms of pricing, workflows, final quality, number of splat, file size, and more, so that you can decide which one best fits your needs. During this video, I will show you the complete workflow step by step, and even how to reduce the file size of your splat by 99% without major quality losses. And no, it is not just about cleaning it up. Before we start, I wanted to say that this is not a sponsored video. Feel free to skip different sections using the chapters below, but you might want to follow along because I will be very brief and you might learn a few things along the way. Let's dive right in. The 5 apps that I'm going to compare are Luma AI, Polycam, Teleport, Kiri Engine, and Postshot. I will use the same exact video input that I took with my phone of a landmark in the beautiful city of Delft and see how they all perform. Let's start with Luma AI. Luma AI has kind of hidden a bit their capturing feature, so you will need to go to the lumalabs.ai website, scroll to the bottom and then click on Capture. Luma AI is free, so you can just upload your own file, and it also uses a profile called ADC. I'm gonna tell you more about these profiles and what they're for, and take this all with a grain of salt, since these are not information that are usually disclosed by the people that make the tool. Once you are there, you can just click and upload your own video, and then you are basically good to go. I have to say that the animation that you get to visualize your capture splat is still the best that you can get out there. And let's give a look a bit at what we have got here. So you see the splats looks pretty good. The colors are a bit more muted, and in some way, especially when you look from the top, when the capture was not ideal, you see that there is even more fuzziness. But from the viewpoint, looks solid without too many floaters around. One thing you don't see much is this internal metal structure that was inside the sculpture. For the rest, the scenes around it, so you see the church in the background and the street, are also somehow in the capture, even though that wasn't really, let's say, the intent, as I walked around the object to scan it. When we look at the actual size of the splats, in terms of both number of splats and file size, with Luma AI you end up at 1.1 million splats and a file that is 268 megabytes. Let's now look at Polycam. Polycam is free up to 1 minute and 40 seconds video. Also probably uses the same ADC model. Since my video was longer, I had to opt in for the paid tier. Let's now look at the file that you get from Polycam. Here immediately you see that when compared to Luma AI, the colors are even more muted, and there are many of these floaters around, more than what we have gotten with Luma AI. That's not per se a bad thing, but certainly something to consider. The other thing you see is that there are some artifacts in a way. Here seems a bit like there is kind of a hole, but on the other hand, we start seeing this metal structure inside. That's nice, because that's, I think, one of the features that are probably hard to capture, and it's interesting to see it here represented. In this case, when we look at the final, again, file size and the number of splats, we are at 1.1 million and 275 megabytes, so very close to what we have seen with Luma AI. Teleport is created by Vario, the Finnish company behind the high-end VR headset. Has a free tier that allows you to import your own video, but you can only get 5 splat a month and you cannot export the output. That's why I end up trying it out for a week. Teleport uses MCMC, the Markov Chain Monte Carlo model. Let me take a quick break to explain you roughly the difference between ADC and MCMC. ADC stands for Adaptive Density Control and is one of the older models. It is a more lightweight model from a computational standpoint, and it builds the splat inside out, and usually it tends to be better for environments. MCMC stands for Markov Chain Monte Carlo and is a probabilistic model. It requires more computational power, and unlike ADC, the approach is more outside in, generating more splats, leading to bigger file sizes. And let's not forget, it is more suitable for objects. There is also another very important consideration to make, because the final output is heavily affected by the number of iterations. Except for one tool in this list, we have no control on the number of iterations, and to my knowledge, that is also not something they have disclosed. So we can just guess. There is also a third and new profile that leads to great quality splats, but people know very little about. But I think I'm getting ahead of myself. Let's go back to Teleport.
One thing to notice immediately on Teleport is that you have two options to see these splats, in SD or HD, where you have a significant difference in number of splats. You can also, in this case, navigate with WASD and look around, go a bit higher, change the center of rotation, and here you see that the structure inside is much more visible from different angles of the scan. Now, how does this compare to the other? Again, this is a bit hard to say if we don't have a side-by-side comparison, something that I'm going to show you later, but hard to say. We need to wait and probably put them side by side. When we look at the file size and the number of splats, we end up with 1.5 million splats and 359 megabytes. Also note that when you are viewing this on the web, you also have the option to go and launch desktop app. And this allows you to view the splats also in VR.
I actually made a list of apps and tools that allow you to view splats in VR. To get it, just get and click the first link in the episode description, join my newsletter, and you will get it directly in your inbox. Kiri Engine allows you to create splats only with the paid tier. I have also interviewed the founder of Kiri Engine, so check out the link in the episode description.
With Kiri Engine, we are now seeing actually, I think, what seems to be a very good splat. Maybe one of the best we have seen if we look at, let's say, how complex the structure inside the heart also is. So it does looks pretty impressive, and honestly what makes it maybe even more impressive is the fact that it has only 737,000 splats and a file size of 178 megabytes.
Postshot is a free tool and the only one you install on your own PC. I recently interviewed Olli Huttunen and he is the one who convinced me in giving it a try. You can find the link to the episode of that interview below. With Postshot, you can get much more control on the number of iterations or the profile that is being used. So let me introduce you to Splat3. Splat3 is a very new profile. It seems to be based on the same inside out as ADC, and it allows you to set up the maximum number of splat, which was possible only with MCMC. That being said, it feels a bit of a mix of ADC and MCMC, and was also mentioned when I asked on the official Discord, but I couldn't find much details about it. If you know more, please add it in the comments. And now let's get back to Postshot. It has several functionalities that are beyond the scope of this video, but I highly encourage you to explore it. I have an RTX 3060. The process went for a couple of hours, and here is the final output, ending up with 3 million splats and 600 megabyte file size.
Now, what we get here on Postshot looks pretty impressive. I think that it's so far the best that we have created so far. The color looks really bright. Everything looks pretty sharp, almost no floater around the heart in the immediate, let's say, perimeter of it. The view dependency looks pretty amazing. The structure inside almost visible from any angle. Now, that being said, it's also true that this uses a different model, indeed Splat3, that I just explained, and also around 30,000 iteration. That is probably beyond what all the others models have made. But again, don't get me on this.
But how do they compare in terms of quality? To compare the look, I'm going to clean the splat and put them side by side on SuperSplat. Let me show you how to do it.
So first of all, we will go to the SuperSplat editor and then import a scene. Here we will load let's start with the one from Luma we have set, and get the scene in place. So SuperSplat allows you to do many things. So to remove these little dots, you can click here, then you see just the splat, and then move the splat around. You can go down here to the translate. You get the gizmo when you can kind of like change the orientation and move it around. After you have somehow positioned it in the center of the scene and maybe you rotate it if it is not the right alignment, what we want to do is really remove all this kind of stuff around. The way to do it is, there are several. You have different selection methods. For this, I'm just going to use the sphere selection tool. I'm going to make it here and then go to the radius, make it bigger, and then try to center it around the heart. And I think this could already work out. Once you have decided what to select, you can set it, and then you can invert the selection. To do that, you can just go to invert or push Ctrl I. Perfect, I think we have got it, and now we delete. And if there are some other splats that you want to remove or other floaters, you can always use the brush tool and then try to get it here at the edge. And also do not remember that if you want to check how many splats are in this cleaned up version, you can always click in here on Super Splat, and this will give you the actual value. And so I've cleaned all the splats, and now let's put them side by side to see who is the winner. We got from left to right Luma, Polycam, Teleport, Kiri, and Postshot. Now, the first thing that is absolutely clear is size. So while you see that Teleport, Kiri, and Postshots, they have somehow a comparable size, the same cannot be said for Luma and Polycam, where Polycam really leads to a very tiny splats, something that you should take into account when you are processing the scan further. And of course, do not forget that you can always change the size of the splats and make changes in Super Splat. Now, that being said, let's maybe give a look at it from a bit up close. When we go and look at the splat itself, you see that for Luma AI we get a bit of it more fuzziness, and there isn't much inside in terms of the metal structure. But nonetheless, it's okay, but nothing, let's say, necessarily impressive. With the Polycam, what you do is that you get what seems like a little bit fuzzy, a bit less fuzzy on the outside, with this kind of like a bit weird artifacts, but you start seeing a little bit of this metal structure appearing inside. When looking instead at Teleport, things start to get better. So the scan seems still a little bit fuzzy, but you get more of this metal structure inside. And yeah, I would say this looks, I feel, better than the other two. Kiri instead is, let's say, I think brings it to a different level. So you see that the view dependency is much more prominent. You get indeed this very vibrant color and sharp contrast. So I think this looks pretty impressive, and you can see that also from the back when you compare it, for example, with Teleport. Let's go now to post shots, and without a doubt, I think that this might be our winner in terms of look. You still see there is some splats, some floating things. This might be also be due to me not maybe selecting it properly, but I think you get an impression. And you know, surprisingly, what you get from Kiri and from post shots are kind of like surprisingly close. As the last step, let's export the cleaned and compressed file and see how far we can get. This also allows me to import them on a platform where you can literally walk through them and decide for yourself which one you prefer. When you are exporting this, you have several options. First of all, you can just go to File, Export, and then export a PLY or the compressed PLY. What you can also do is reduce the harmonics. Harmonics are basically the properties of the splats that define the view dependency effect, and you can kind of like see them in here in action when you, so these are all the different splats, let's say the center of it, and then you can view these harmonics that turns those points into ellipsoid, to which the property change based on the side you view them. Now, you can see this especially clearly when you bring in one of the models that I already exported with less harmonics. So in here, let's go back to the standard view. And then we go to settings, and these SH bands are the one that affects this view dependency effect. And you see that when I decrease that those two models match because this is the one that I already exported with it. So again, with 3 bands or 0, you see the difference. And this affects the view dependency, especially for glossy models, but have a much less visible effects for something that is solid, it's not glossy or metallic. So something that you can consider when exporting and how crucial it is for the look of your scene. Now, in this case, we can just do this, decrease it to 0, and then allow to export it so that I can upload it on a web platform.
I've then applied the same type of compression to all scenes, and here are the final results.
For Luma AI, we end up with a file of 183,002.9 megabytes. After cleaning, despite the size and the models seemed very similar with Polycam, we end up with something that is dramatically smaller. Now, on Teleport, we end up with something that is 110,000, 1.7 megabyte, so still quite a good output given also the quality that we have seen so far. With Kiri Engine, we end up with 236,000 and 3.7 megabyte, and last but not least, our most beautiful capture from Postshot got 475,000 and just a file of 7.4 megabytes, meaning around a 99% reduction in file size.
So which one is the best tool? I think it's up to you to decide. I have created a gallery where you can literally walk through the cleaned and compressed splats on web, mobile, or even in VR with info on the final specs. If you are looking for other ways to explore Gaussian splatting in VR, remember to subscribe to my newsletter and you will get a list of 11 tools that you can use to explore them either on Quest or Vision Pro directly in your inbox. Also, do not forget to check some of the interviews with the founders building this tool and more incredible experts like Holly Huttunen, who was also a guest at the show. Thank you very much, I hope you enjoyed the video and don't forget to subscribe.